All right, so in this particular lecture, we're going to talk about text summarization. It's a very short lecture, but it does have some tools that we can make use of. And actually, summarization takes from some of our other types of topic modeling tools and applies them so that way we can actually summarize documents. Now, if I were looking at how this might apply to us in the future, this might be just something for us to know how it works. But in general, if we wanted to get a specific document summarized, it might be better just to plug it into AI and ask for a summary. But knowing how things work and knowing actually how AI performs it can be very helpful to us. So in our in our course online, I have the text summarization file. And we're going to be using a lot of the same stuff that we have in the past. So let's go ahead and execute this. And we will go ahead and make sure that all those pieces are in place. And now let's do some wrangling of our documents. By the way, in this case, I just had this elephants file. And if you open it up, you can just see it has some basic information that you would consider from Wikipedia or something like that about an elephant. So in order to read this document, we're going to use an open function, and we're going to put read at the end. So that way, all of the data that gets that is from this file will be opening that file. It'll be encoded with UTF-8, which is a good standard for us to follow. And then, of course, it'll read it. So it'll be then held into this variable called document. Now we want to tokenize each sentence. So we're going to use the NLTK sent tokenizer, and then we are going to display the sentences that we have. So let's go ahead and execute this. All right, so we can see now that we have the first 3 sentences. There are 29 of them. The first 3 say elephants are large mammals of the family Elephantidae and the order Proboscidia. I think I said that absolutely wrong, but you guys can make fun of me while you're sitting at home. Thank you. All right, so we are going to do a couple of things. We're going to flatten our corpus. We're going to compute the number of n-grams, and n-grams is like bigrams, trigrams, unigrams, whatever we might want to include. And then we're going to get the top n-gram value. And our default for this is going to be an n-gram value of 1. But what we're actually going to do is take our document. So let's go ahead and put that in here. And we're going to ask for the n-gram value of 2. So this will give us bigrams. And we're going to ask for the top 10. So now we have the bigrams. And I think that I did something wrong. So I apologize. I don't want the document. Actually, what I want is the sentences from our, here we go. We want to apply it to the sentences and get bigrams that are there. And just to let you know, what I'm really talking about is I needed this variable right here. So here we go. So we have a lot of bigrams. And if you look, this also includes, here we have the comma, space, and the word and. That is a bigram, and it occurs 9 times. We have a period, space, elephants, and it occurs 7 times. And you can already gather that some cleaning has to be applied to this document for us to get some better meaning out of this. So let's go ahead and do some basic cleansing. Basically, I'm going to take out all the repeated lines and line returns and any of the extra spaces, and I'm going to strip everything out, and let's kind of see what happens afterwards. All right, so now this is my new document. So let's go ahead and apply this. So let's get sentences. We're going to look at the sent tokenizer one more time. And this time we're going to do all of this cleaning so we can see now how things are going to change for us. We are going to use the NumPy vectorizer on that particular function. We're going to normalize our sentences, and now let's take a look at what we have. So now this is the change to our document. So that basically is a long way around saying that we have a document, and by looking at it, we needed to obviously make some changes to it. So we did some data cleansing. All right. So if you think about our text analytics process, that's kind of what we do. We pick our corpus, we do some transformations. Now we have to do some feature engineering, or representing our text with the features that are extracted from it. And in this case, we're going to use our TF-IDF vectorizer. So with that being said, you guys should know how to use a TF-IDF vectorizer by now. We set up our vectorizer model. We do a fit transform. And then we convert that to an array, and then we need to get feature names out. And let's take a look at this particular item. So what I did, instead of getting the entire TF-IDF matrix, I just wanted to specify that we had 223 features and 29 documents, or in this case, 29 sentences. Now, here's how we're going to start doing some text summarization. So this is a type of topic modeling. Now, on the left-hand side of this equation, we have our basic term by document matrix, or term by sentence matrix in our case. And what this can be broken down to is a product of 3 different matrices, or matrices. We can create a term by topic matrix. We can just have a single vector of topic importance with some scoring, and then of course a topic by document matrix. Now, basically you can see that we are using this topic as an intermediary that will then multiply itself out, and then we get our term by document matrix. But one of the things that we have right now is that term by document matrix. We don't have all of the others. So by using algebra, we actually want those basic topics that are going to be in that center component on the right-hand side of this equation. So in order to do this, we're going to use what's called singular value decomposition. And single value decomposition is similar to LDA, which we did in the previous lecture, but this time singular value decomposition is more synonymous with latent semantic analysis, or LSA. So using that tool, we're going to be able to extract those topics in that middle matrix. And here I have everything set up for us. And the most important thing right here is this particular library that we're going to import, and that will allow us to do those things. So what I have here, the only thing that we need to do is include our matrix that we extracted, or our term by document matrix, and that is up here from the previous block. We're going to put that in here, and then we're going to be able to get all those pieces extracted. So this one little algorithm extracts all those pieces for us. We had to identify how many sentences that we wanted, and this is to create a summary. How many topics might actually be in this. So we can mess around with these 2 variables and get some different sizes. But now that we said that there's 2 topics, we now have our term by topic matrix, which is the number of terms or features, 223. And we said 2 topics, so it should be by 2. We have our singular vector model of topic importance with basically 2 values. And then we have our topic by document matrix. Remember, we had 29 sentences and, of course, the 2 topics. So all those things should jam with what we're dealing with. All right, so in order to make sure that we have sentences that are aligned with these 2 major topics that we've defined, we're going to set a threshold value of 0.5. You can always change this as well and say a sentence only is important if it is above or below that threshold. We can raise that threshold or lower that threshold. So here's how we apply this. So if we look right here, this entire thing, we're going to perform a Euclidean distance type of application by squaring our topic by, squaring our topic by document matrix and squaring our singular values. And then we're going to get the dot values of those, or the dot product values of those, and then we're going to get the square root of all those pieces. And that will give us salient scores of each document as it relates to the topic. And what this allows us to do is using those salient scores that allows us to put together a summary of the document. So let's go ahead and execute that. And with that being said, we should now have 5 sentences that are looking at 2 main themes that are from the document, and it puts those sentences together and gives us a brief summary based on the idea that there are 2 themes there. So let's read this. Elephants are large mammals of the family Elephantidae and the order of Proboscidea. 3 species are currently recognized: the African bush elephant, Loxodonta africana, and the African forest elephant, L. cyclotis, and the Asian elephant, Elephas maximus. Elephantidae is the only surviving family of the order Proboscidea. Other now extinct members of the order include Diontheres, Jomphotheres, mammoths, and mastodons. Elephants can live up to 70 years in the wild. Elephants are used as working animals in Asia. So what you can do, if you choose to, you can try going to 6 sentences, 3 topics, and this time we can put a threshold value of 0.6. And we can run all cells just to kind of see what happens. And now you can see that we get a different summary. So by varying those values that I just shared, the threshold, this was supposed to be 0.6. Let's run that one more time. And now you get a different type of summary. So this can help you kind of change or edit your summarization models, but keep in mind that these are 6 sentences now in this case that are most relevant according to our topic modeling of this document that now gives us a short summary. All right, so as I mentioned, this was going to be very short, very brief, but it's a really good example of text summarization, and it is based on topic modeling. All right, so if you have any questions, please let me know, and I'll see you in class.